this episode of Finno-Ugric machining, we are continuing the reparation or fixing the oil leak in the variator pulley. And now I have been shopping, not a lot, under 10 euros, but it's this. Well, we only need one, but the sizes of these are standardized. This is a seal, not a marine mammal, but a seal, oil seal for shaft. It has a rubber lip here, and then it has a spring going around there inside. And then these have standardized sizes. So the outer diameter, in this case 47 millimeters, exactly what I need. The shaft diameter nominal in this case is 34 millimeters. They of course they didn't. They did have 32 millimeters. Which was actually the original size of this shaft, but they didn't have the 33 millimeters, which is, well, so I need to ream a little bit more. You could go a little bit under, but then the seal is not proper. So a proper shaft diameter for this one is 34 millimeters. These are really affordable and less pain than that I thought. So the first thing I do now is to do reaming, and it's the whole millimeter of that. So I won't show that one for you, nor do I want to show the result of the sweat, etc. The next thing you will notice, well, maybe I'll show a little bit. But the next thing is going to be to start machining the shaft itself. Once we have a proper seal and we have the diameters known, we can go on from that. Oh, and that was 3 passes. So 27 more passes to go. So I decided not to ream 1 millimeter away from this diameter, making it 1 millimeter bigger. Reaming is really, and now I know it for a fact, it's really just the finishing touch. So I succeeded in taking away 1/10 of a millimeter, and it was already like so now what I have done, let's see. In order to get this done, taking away the to the 34 millimeters. So first of all, forge our chuck. Please notice the aluminium spacers here. These for two purposes. First, they protect this piece from the jaws, and then they allow some movement, because you have to dial. This is now dialed both ends under 1/100th of a millimeter. Well, it was really fiddly. Once you get this side okay, and then you moved here, it was something like 20/100ths of a millimeter away. Then you knocking with this one, a little bit this one, so you get it straight. Then this end was again out of measure. But it was an iterative process. 5 times, maybe 7 with this thing. I have done a thing like this. This is very practical, really practical. And then now it's straight. This is a cheap Chinese steady rest, which is yeah, okay. It's not the best possible, but now, and it's actually just touching this one, so it holds it in place somewhat. And then this is a boring bar I made something like half year ago, and I have bored this with this one. This is quite steady. There is a carbide insert here, and then this is just ordinary hot rolled steel. It's still quite a long stick out, and furthermore I have done so that when I approach this end, there will be a hard stop. Now it's a hard stop. I have made these wiper covers earlier. The original wiper covers were plastic. These are actually steel, and well, they are a lot better. And of course the same this side too. Yeah. Okay. So happy boring now. I will take some. I don't know how much. Maybe. Well. Let's see, 1/10 of a millimeter at a time, and that's a maximum. Let's see how it's singing. Yeah, but luckily I have this VFD, so I can vary my speed continuously. If it starts to sing, you just adjust it a little bit and then keep on turning back and forth, and it will do quite well. Okay, now. Let's stop babbling and start doing my lathe, this diameter to the correct size. Okay? Very important. Whatever lathe work you are doing, these are really important. Yeah. And they are cool. Yeah. That's the power switch there behind, and it should start, yes. This one we don't need anymore. Let's see, and this is a chuck key. Never leave it there in the chuck. And okay, now the speed. Let's start with I think this one could be probably correct. As you can hear, this is quite a silent thing. Now, actually I need to go back there. But it's cutting. Yeah. Okay. I touched this carbide with diamond file before I started this, so it's very sharp at the moment. And this material, you need to have the sharpest possible tool. Well, here is the boring going on. As you can hear, there is no chatter, despite the very long stick out. Well, the reason why there is no chatter, one thing I have learned is to put the center this a little bit above the center line. That helps. And then, of course, the tip needs to be really sharp. And then that one. This helps. You can adjust the speed as you wish, and after that, this is the result. No chatter. And the surface finish, if you can look inside there, it is actually quite good. But I still ream it. At the moment it's going on, it should become 33.85 millimeters. So I make it 100 of a millimeters, maybe 200 of a millimeters too large. This is to accommodate the oil. Okay, and of course this steady rest. Actually, this steady rest doesn't help for this chatter at all. It is there just to as a security, so it doesn't start wobbling around. And this noise you can now hear. There is a hole there, and this will make this noise. And then I noticed that even though this is bronze, but it's aluminium bronze. So this means that you really should use some cutting oil here. It cuts. If you do it dry, it shatters like well, it shatters. Okay. So I keep on boring, and once I'm at correct diameter, I will ream it just for the finish.